Hello everyone, in this project we analyze the rental prices in Abbas Ağa neighborhood located in Beşiktaş, Istanbul. This is a central and popular area where rent values are influenced by features like apartment size, furnishing status and building amenities. We manually collected the dataset from real estate listings on Sahibinden.com. It includes key variables such as rent price, area in square meters, number of rooms, floor level, total floors, elevator and parking availability, and whether the apartment is furnished. For our analysis, we used R programming. Packages like RedExcel, Deployer, ggplot2, Psych, and CAR help us with importing data cleaning, visualizing, and running models. If a package wasn't installed, it was automatically added and loaded. We loaded the Excel file into R and started organizing the data for easier handling. To make the analysis smoother, we renamed Turkish column names. For example, Kira became rent and Brut alan became area. We cleaned the dataset by removing any missing values in critical columns like rent or area. Even though there were no major NA values, we made sure the data was ready. We also converted the furniture column into a labeled category furnished or unfurnished. To ensure accurate results, we used the interquartile range method to remove extreme outliers from variables like rent, area, floor, and total floors. Apologize for the odd setup. Due to technical limitations, I wasn't able to record my voice and screen simultaneously, so the narration had to be added as a voiceover afterward.
Hi, let's begin with the descriptive statistics of the cleaned dataset. We analyzed k numerical variables such as rent, area, floor, and total floors using the describe method. This provided essential metrics like mean, median, standard deviation, and skewness. Understanding these central tendency and variability measures helped us form an initial idea of the dataset structure before proceeding to deeper statistical tests. To visualize the distribution of rent values, we generated a histogram. Most listings fall between 20,000 and 35,000, with a few outliers beyond 40,000. This creates a slightly right-skewed shape, which is typical in real estate markets where a few luxury properties inflate the upper end. Next, we examined the distribution of categorical variables using frequency tables. For example, the furniture variable allowed us to count how many listings were furnished versus unfurnished. This kind of breakdown gives us an understanding of categorical proportions and help us prepare for group-based comparisons like t-test. To determine whether we could use parametric tests, we checked for normality. We applied the Shapiro-Wilk test to the rent and area variables. The null hypothesis here is that the data follows a normal distribution. Since both p-values were greater than 0.05, we failed to reject the null hypothesis. This means the distribution can be treated as normal, a green light for the t-test, and confidence intervals. Using the t-distribution, we calculated a 95% confidence interval for the mean rent. The interval ranged from approximately 20,000 to 25,000. This means we are 95 confident that the true average rent in Abbas Ağa lies within this range based on our sample. Finally, we concluded a one-sided t-test to see if furnished apartments had significantly higher rents. The null hypothesis stated there is no difference, while the alternative claimed that furnished units are more expensive. The p-value was around 0.17, which is higher than 0.05. So we failed to reject the null hypothesis. Despite expectations, our sample did not show a statistically significant rent difference between furnished and unfurnished apartments.
Now I'll present the final results of our analysis, starting with the regression model. We created a multiple linear regression model using 3 predictors: area, floor, and total floors. Among these, only floor was found to be statistically significant. Its coefficient was negative, meaning that as the apartment floor increases, the rent tends to decrease. This aligns with our earlier correlation results. The adjusted R-squared value of the model was 0.235, which means the model explains about 23% of the variability in rent. Although not very high, it shows that floor level is a meaningful factor, while area and total floors were not significant predictors. Next, we evaluated the residuals of our regression. The residual plot showed that errors are fairly evenly distributed, and the QQ plot confirmed that the residuals follow a roughly normal pattern. This supports the assumptions of linear regression. We also conducted a one-way ANOVA to test whether the number of rooms significantly impacts rent. The p-value was 0.253, which is not significant. This suggests that room count does not have a meaningful effect on rent in our dataset. Then, we ran a chi-square test to check whether furnishing status is related to elevator presence. The p-value was 0.7, which means there is no statistically significant association between these two variables. In conclusion, our results show that floor level is the most influential factor on rent prices in Abbas'a. Factors such as area, room count, and furnishing were not statistically significant. Thank you for listening.